our building is located in San Guillermo, Isabela. So let's go to figure 208-2D from NSCP 2015. So located in San Guillermo, Isabela, let's say ito po yung building location niya. So measuring perpendicularly using this scale, the nearest fault line is ito po. You use this scale, let's say that is 12 kilometers. So yan po ang ating distance. And then ang gagamitin pa nating seismic source type is type A. So from table 208-4, ang ibig sabihin po niyan, yan ay magnitude 7 to 8.4. Yan po ang pinakamalakas na magnitude. Next, we will determine now the near source factor NA. So the closest distance is 12 kilometers, or that is greater than 10 kilometers. So A, gagamitin natin. So ang ating NA is 1. Next is near source factor NB. So you'll notice that the distance is between 10 and 15. So we will do ratio and proportion or interpolation. So from 1.2 to 1. Lumalabas na 1.12 ang ating NV. Next is wind load. Ang ating building po ay less than 18 meters. So we will use low-rise buildings, component and cladding simplified procedure. That is on page 2-138 of NSCP 2015. So step 1, determine risk category, see table 103-1. Ito po yan. So also you see table 207-3, ang ating occupancy category ay 4. And then, step 2, determine the basic wind speed V. Now, using this map, figure 207A.5-1A, ang location po ng building ay nasa 290 kph na zone. Ito po. So, yan po ang gagamitin nating wind speed V. And then, step 2, applicability risk category, see figure 207A.5, 1A, B or C. Ang ating category ay C. Ito po. And then, step 3, we will determine wind load parameters. We start with topographic factor KZT. We will assume topographic factor KZT equal to 1. That is for generally flat terrain. Next is the importance factor I. Ang gagamitin po natin ay 1. That is for standard occupancy with category 4. Ito po. And then, our mean roof height H is 10.7. Mean roof height means the distance from the middle of the truss height down to the ground. So you'll notice that this is marked red, meaning input po yan. And then kukumpitin po natin yung adjustment factor based from this figure 207E.5-1. You'll notice that our mean roof height 10.7 is between 10.5 and 12. And then, our exposure category is C. So, we will be using this column. So, pagtapatin pa natin si 10.5 and 12 dito sa C. So, mag-interpolate po tayo. So, from 1.45 to 1.49 and using 10.7 as your x-axis, and then ito 1.45, yan po yung sa y-axis. Lumalabas na ang ating factor is 1.45. So that is by interpolation. NSCP 2015 is based from ASES 7-10. So what are components and cladding? Ang cladding, yan po yung roofing sheets, and then component, yan po yung purlins and trusses. So cladding, yan po yung nagre-receive ng load, and then yung component, yan po yung dyan po trina-transmit ng roofing sheets yung and load. So ito po ang ating figure. Ito po yung shape of roof structure. So mapapansin nyo na gable type siya. For our wind loads, we will consider only zones 1. Ito po yung nasa gitna. Zone 2, yung nasa edges. So dito sa edge, sa gilid, sa top. Tsaka yung zone 2 din sa baba. And then finally, we have zone 3. Yan po yung nasa corners na. Next, we now identify the dimensions of our building. So ito po, building with fronting wind. So that is your B. So that is 13.5 meters. So that is the dimension fronting the wind. And then the bottom chord length, or that is W, that is 13.1. Ito po yung W. And then truss spacing L, that is 2.25. So napansin nyo na red po ang ating mga inputs. And then our purlin spacing is 0.8. And finally, the height of truss is 2.2. And then you will notice that the mean roof height H is from the ground up to the mid height of your truss. Now let's compute the area effective of the truss. That is the minimum of two equations. So that is LW, or 9.5 square meters. So if you will compute 2.25 and 13.1, you will multiply that. So that is 2.25 times 13.1 is 29.475. So ang gagamitin natin ay 9.5 square meters. And then for effective area for purlin, the computation is the maximum of these two equations multiplied by L. So L all over 3 is 2.25 divided by 3. And then S. So lumalabas na 2.25 divided by 3. Multiply this by L na 2.25. So 1.6875. And then we multiply S 0.8 and our length 2.25. So that is 1.8 square meters. So yan po ang gagamitin natin. 1.8 square meters. Okay. Next, we now determine the net design wind pressure P-net. So, ang ating basic wind speed V ay 290. Notice that 290 is between 250 and 300. So, again, mag-interpolate na naman tayo. So, remember that we are using zones, considering zones 1, 2, and 3 only. So, remember, ito yung zone 1, zone 2 sa sides, and zone 3 sa corners. So, ito po. And then, ang gagamitin natin ay roof angle is from 7 to 27 degrees. Okay? So, ito yung zones. May zone 1, then may zone 2, tsaka may zone 3. Ito naman ang effective wind area. Take note that the effective wind area is up to 9.5 square meters only. Okay, so meron tayong 1 tsaka 2. So, ang unang kukumpitin natin ay for Berlin. So, ito. So, notice that 1.8 is between 1 and 2. And then, ang wind speed ay nasa 250 tsaka 300. So, ano ang gagamitin natin dito? Tsaka yan. Okay, so let's continue. So, we will now do the interpolation procedures. So, ito po ang 290. So, yan. And then, ito naman yung galing sa table. So, we have zone 1, 250. Okay. So, yung area 1, yung 1.2 tsaka 1.9, yan yung windward and leeward pressure. So, manggagaling dito, yan 1.2 tsaka negative 1.9. Then, this is windward and leeward pressure. So, mapapansin nyo na yung windward is 1.2 positive. Ibig sabihin, pressure yan. Itunutulak yung surface. And then, for leeward, negative 1.9, meaning it is suction. Next, we now go to 2 square meters na area. We have 1.09 and negative 1.85. Yan po ngayon ang ilalagay natin dito. Okay, so 2, 1.09 and negative 1.85. So, remember na yung area natin ay 1.8. So, you do interpolation again. So, you get 1.11 and negative 1.86. And that's for 250. And now we go to 300 wind speed. So, sa area 1, we have 1.72 dito sa windward and negative 2.74. Yan ay nasa area 1 na 1 square meters. Next, for 2 square meters sa 300 na wind speed, you have 1.57 sa windward and negative 2.66 sa leeward. Yan po ang ilalagay natin dito. Okay? Next, for 1.8, you do interpolation. Okay, so you have 1.6 and negative 2.68. Yung 1.6 na yan, that is between 1.7 and 1.72. Yung negative 2.68 is between negative 2.66 and negative 2.74. Now, let's go to our actual wind speed na 290. So, remember, 290 is between 250 and 300. Next, we will interpolate this. So, windward area 1 for 290. This is taken from 1.2 and 1.72. Next, ito namang 1.474. Nanggaling yan dito sa 1.09 tsaka itong 1.57. So, this is windward area 2. Then, this is also windward area 2. So, that's how you get 1.474. Next, dito tayo sa negative 2.572. This is interpolated between negative 1.9 tsaka negative 2.74. And then, itong negative 2.498, that is interpolated between 1.85 negative tsaka negative 2.66. And then, from this values from 1.474 to 1.66, mag-interpolate tayo from 1 to 2. And ang ating x ay 1.8, makukuha mo ngayon si 1.5. And then mag-interpolate na naman tayo between negative 2.498 and negative 2.572. Tapat mo si 1.8 dyan, makukuha mo si negative 2.51. So, ito ang kailangan natin, yung 1.5 tsaka negative 2.51. But, this is only for zone 1 of wind speed 290. You do the same procedure for zone 2. Okay, for zone 2, this is zone 2. And you get 1.5 and negative 4.19. You do the same procedure again for zone 3, and you get 1.5 and negative 6.27. Next, ang ating purlin spacing ay 0.8 meters. And then our adjustment factor is 1.455. And our KZT is 1. After computing all the wind forces, we now tabulate them here. So for zone 1, we have 1.5 and negative 2.51. Ito siya. Dito natin ilalagay. And then for zone 2, we have 1.5 and negative 4.19. And for zone 3, 1.5 and negative 6.27. So now, we compute the loads for our purlins. So for zone 1, we have 1.749. That equation is adjustment factor times KZT times P net 9 times S. Okay, so let's do that. So that is equal sign times adjustment factor 1.455 times KZT na 1 times P net 9. Ito, yung 1.5 times spacing S na 0.8. Then, you press enter. Yan. And then, ito namang negative 2.96. That is equal to 1.455 again. This time, we use negative 2.51 times nakalimutan ko yung KZT times spacing na 0.8. Okay? So, ganyan. That's also how you do for zone 2 and zone 3. Ngayon, bakit hindi na-highlight ng yellow itong zone 3? Remember that zone 3, yan yung nasa corners. So, ang gagamitin lang natin ay yung zones 1 and 2. So, we will be using this for purlin loads. Kukumpitin natin ngayon yung effective wind area computation for truss. So, we have here two equations. That is the product of LW and 9.5. So, kukunin mo yung minimum among the two. Okay? So, you multiply L and W. So, that is 13.1 times 2.25. Obviously, masyadong malaki na yan. So, ang gagamitin natin ay 9.5 square meters. So, remember that our wind speed is 290. So, you have to interpolate between 250 and 300. And then again, our truss angle is nasa range ng 7 to 27 degrees. So, meron pa rin tayong zones 1, 2, and 3. But, this time, hindi na natin kailangan mag-interpolate ng area. Why? Kasi 9.5 na ang ating gagamitin. So, we have here for 250, we have 0.85 sa windward and negative 1.72 para sa leeward.